Hello everyone, welcome back to my channel. So in this video we are going to learn about applications of SSB and VSB signals. Okay, so we'll see the basics of VSB modulation also, only basic points which are required, and the applications, okay, of these two modulation schemes. So first of all, SSB, single sideband modulation. So SSB, very important point, SSB is used in the transmission of voice signals only, because the reason is because they means voice signals have sufficient guard band of 600 hertz. Okay, so why this happens is practical filters does not have sharp cutoff frequencies. Okay, so due to this, complete elimination of one sideband is not possible practically. Okay, so due to this reason, SSB is used in the transmission of voice signals only. Let me explain very clearly. Okay, so if you take an audio signal, its range is from 20 Hz to 20 kilohertz. Okay, so its range is from 20 Hz to, if you draw the spectrum, it will be like this. Okay, so this is 20 Hz to 20 kilohertz, and this is minus 20 Hz, minus 20 kilohertz. So the guard band here, is only 40 Hz. So guard band is the frequency gap present between two signals. Okay, so the gap here is only 40 Hz, 20 Hz minus of minus 20 Hz. So 20 Hz minus of minus 20 Hz is only 40 Hz. So only 40 Hz is not possible. So sharp cutoff frequencies is not possible. So when you have an SSB signal like this, so suppose if you are transmitting upper sideband, so okay, this sharp cutoff frequency is not possible. Okay, so suddenly the amplitude will not decrease from a highest value, an amplitude value to 0 suddenly. So it takes some frequency gap, it required some frequency gap, that is complete elimination is not possible. So this will be the part of other sideband also. Okay, so there should be some so this is the practical spectrum of any practical filter. Okay, so this is the spectrum of any practical filter. So sharp cutoff frequencies is not possible, so thereby there should be some frequency gap present, so that the frequency or the gain of the filter decreases gradually and becomes 0 eventually. Okay, so here the guard band is only 40 Hz, so even if it decreases, it may coincide with the next band because frequency gap is very low. Okay, so in the case of video signal, the guard band is 0, so there is no guard band present actually. Okay, so guard band is going to be 0 because its range is from 0 to 4.5 megahertz. Okay, so if you draw the spectrum also, this will be like this. Okay, this is 4.5 megahertz and this is minus 4.5 megahertz. So there is no frequency gap for video signal, but for voice signal range is from 300 hertz to 3.5 kilohertz. So 300 hertz to 3.5 kilohertz. So if you draw, this is 300 hertz and this is 3.5 kilohertz, and the next signal, even if you take, so it will be like this. So this will be minus 300 hertz, this will be minus 3.5 kilohertz. So there is a frequency gap of around 600 hertz. Okay, so of around 600 hertz there is a frequency gap. Even though we use a practical filter, it is decreasing its amplitude gradually, so gain decreases gradually, so that there will be sufficient guard band present in voice signal. Okay, so sufficient guard band is present in the voice signal, so it decreases gradually, then also there will be no problem. Okay, so that is the reason why SSB is used in the transmission of voice signals only, because they have sufficient guard band of 600 hertz. Okay, and this is the why this is happening. Practical filters does not have sharp cutoff frequencies. Okay, so that is why complete elimination of one sideband is not possible practically. So even though there is presence of the other sideband, it is not going to affect the other signal. Okay, this signal transmission is not affecting the other signal transmission. So that is the reason why, due to sufficient guard band, SSB is used in the transmission of voice signals only. Okay, so now we will see the other type of modulation scheme, that is vestigial sideband modulation. Okay, so in short we will call it as VSB modulation. Okay, vestigial sideband modulation. So it is practical case of SSB only. Okay, it is not a new concept. So if in SSB, if you use practical filters, then it becomes vestigial sideband. Okay, so when you use practical filters, what will happen? So along with the sideband, along with the required sideband, some part of other sideband is also there in the SSB. So that is why SSB is used in the transmission of voice signals only. Okay, so in vestigial sideband modulation, along with the required sideband, some part of other sideband is also transmitted, which is called vestige, Okay, so that other part of the sideband, or some other part of the sideband, is called as vestige, and corresponding modulation is called as vestigial sideband modulation. Okay, so that is the only difference between SSB and VSB. Okay, so if you use practical filters in the case of SSB, then that becomes VSB. So how will be the spectrum of VSB signal? So if you take VSB, then if you are transmitting upper sideband, so upper sideband will be transmitted, so that is from FC to FC plus W, and some part of the other sideband, that is some part of LSB, is also transmitted in the case of VSB. So this part is called as vestige. Okay, so this part is called as vestige. The other sideband part is called as vestige. So here it will be, what will be this? This will be FC minus FV. So where FV is called as bandwidth of vestige. Okay, so the bandwidth of vestige, FC minus FV. Okay, so if you take the bandwidth of this vestige only, so the highest frequency is FC and the lowest frequency is FC minus FV, so you will get again FV. So FV will be the bandwidth of this vestige part only this part. Okay, so for only this part, this is the bandwidth. So what will the and on the negative half also you'll get the same thing. Okay, so if USB is being transmitted, some part of LSB will also be there. So this is minus FC, this is minus FC plus FV, this is minus FC minus W. Okay, so this part is called as vestige. Okay, so this part is called as vestige, right? So what is the bandwidth of VSB signal? I am not talking about only vestige. So total VSB signal, the highest frequency is this and the lowest frequency is this. So highest frequency FC plus W minus lowest frequency is FC minus FV. So it will be FC and FC gets cancelled, so you have FV plus W. Okay, so bandwidth of vestigial sideband is equal to FV plus W. So W is the bandwidth of SSB signal, and some vestige is also added, that is some part of other sideband is also added, so that bandwidth will also be added in the case of VSB. Okay, so what can we write is bandwidth required for VSB is very much greater when compared to bandwidth required for SSB. Similarly, the power required to transmit VSB signal is greater when compared to the power required to transmit SSB signal. Okay, so that is the only these are the differences between SSB and VSB. Okay, so the important point here is vestigial sideband is used in the transmission of video signals only. In the transmission of video signals only. Okay, so this is very important point, and this is the application of VSB. Okay, so why it is only used in the transmission of video signals? So we can't use AM or DSPSC. Okay, so video signal bandwidth is frequency range is 0 to 4.5 megahertz. So bandwidth is going to be 4.5 megahertz. Okay, so along with the guard band it is around 5 megahertz for a video signal. Okay, the bandwidth of any video signal with guard band is around 5 megahertz. So if you use AM or DSBSC, so AM, the bandwidth of AM signal is twice the message signal bandwidth. Similarly for DSB also it is twice the message signal bandwidth. So bandwidth required here is around 9 megahertz. So more bandwidth is going to be wasted. And SSB can also be not used because there is no guard band. Because of no guard band present, SSB modulation also cannot be used in the transmission of video signals because of no guard band. Okay, so complete suppression of one sideband is not possible in the case of video signals using SSB. Okay, so SSB is also not used. So only choice which you have for the transmission of video signals is VSB modulation. Okay, so that is the reason why VSB modulation is used in the transmission of video signals only. Okay, so this is very important point you have to remember. Okay.